Welcome to Ready to Derive. In this video, we will be getting an introduction to polynomials. Most importantly, what is a polynomial? Poly is from the Greek, meaning many. Nomial is from the Latin, meaning name, but in this setting with polynomials, it means terms. So along those lines, we will learn about essential terminology and features of polynomials. We will learn a review kind of how to combine like terms, thinking about the distributive property, and we need that because we need to be able to add and subtract polynomials. So without further ado, let's begin. So let's get into a little terminology, in particular the meaning of the word term in mathematics. And this is a number, a variable, or the product of a number and one or more variables. So let's get some examples of terms. So it could be a number, could be a variable, so it could be just x, that's an example of term. The product of a number and a variable, so but we could have like pi times y squared, and or the number and one or more variables. So let's just do this, -3 a squared b c cubed, just to be creative. So some terminology. We need to know what we mean by the coefficient part of the term. A coefficient part of the term is the number part. So that's obviously 5. Now what's not shown here with just x is there is a number in front of that, that's 1. So that's the coefficient. Pi y squared, the coefficient is pi. And the last one, the coefficient is -3. Now we have to talk about the degree. The degree is the exponent of the variable, or if there's more than one variable, the sum of those exponents. Now, in the first case, it doesn't look like there's a variable next to the 5, but if we acknowledge that this could be 5x to the 0 or 5y to the 0, whichever variable you want to use, the degree is 0. So any constant term, any term that's just a number, always is a 0 degree term. The degree for x, well, it's not written, but the exponent is 1. So that degree is 1. For pi y squared, the exponent is 2. And the only place where we have to get a little more creative is here, where we would need to add the exponents. So 2 plus 1 plus 3 equals, the degree of this is 6. We'll mostly be dealing with single variables as we look at polynomials, but that's a good fact to know. So now that we know what a term is, we can define a polynomial, which means many terms. So it is a sum and or difference of a finite number of terms with non-negative integer powers. What exactly would that mean? That would mean 0 is non-negative, 1, 2, 3, etc. So no negative integers and no fractional exponents. So an example of a polynomial might be 8x squared yz minus 3y squared plus 7. That's a polynomial in 3 variables. What could we do to that to make it not a polynomial? Well, we could make that exponent of squared -2. We could make the y squared, we could, let's see, make it y to the 1/2. And we automatically violate what it means to be a polynomial. Now we are going to be looking at polynomials in one variable for this study. And I'm going to introduce some new terminology. Rather than define each of them, it's easier to kind of just illustrate by example. So we'll have some examples of polynomials. So here's one. What does it mean to write a polynomial in standard form? It means to sort of organize the terms so that the term with the highest degree is first, and then it goes in descending order. So that would mean 4x cubed would come first, then 3x squared, then 5x, understanding that that exponent is 1, and then finally -6, which has a degree of 0. The leading term is, in fact, the very first term with the highest degree. Once it's in standard form, then of course it's the first term. So that would be 4x cubed. The leading coefficient is the number in front of that, or the number, the coefficient of that leading term, obviously, so that's 4. And the degree of the polynomial, of course, because we have many terms and each term has a degree, we define the degree of the polynomial to be the degree of the leading term, which is 3. So here's another example. Now, when we put this in standard form, we must observe that the negative is with the x squared. So we have -x squared minus 2x plus 7, right? Assume that there's a plus there. So the leading term would just be negative x squared. The leading coefficient would be negative 1. Oh, sorry, let me just get rid of that errant mark. And the degree of the polynomial, right? That's the degree of the leading term, so that's 2. Let's do another example. 1 minus 9x to the fourth. So that would be minus 9x to the fourth plus 1. The leading term, 9x to the fourth. Leading coefficient, negative 9. Degree of the polynomial, 4. And finally, we have this, well, standard form. It is in standard form. Leading term, leading coefficient. So 8x, we'll just write that. The leading term is 8x. The leading coefficient is 8. And the degree, even though it's not written there, is 1. And we have a few other terminologies. So trinomial. This when a polynomial has 3 terms, it's called a trinomial. When it has 2 terms, it's called a binomial for 2. And when it has 1 term, like the last one, 8x, it's called a monomial. If it has more than 3 terms, then it's just called a polynomial. So before we get into adding and subtracting polynomials, we have to understand what it means to combine like terms. And to do this, we really have to think about the distributive property backwards. So the distributive property backwards says that if you have a times b and then a times c written like that, you can effectively rewrite it as a times b plus c, because obviously the distributive property would allow you to multiply that back out to remove the parentheses. Now this is kind of helpful in analyzing something like 3x plus 5x. So 3x plus 5x, I mean, you probably already know it's 8x, but why? Well, if you think about it, x is the common factor to 3x plus 5x. So if you take x out, you could write it like this. If you say put x outside and then put 3 plus 5 in there, it's really one and the same, right? Because x times 3 would be 3x and x times 5 would be 5x. And then you can do order of operations, PEMDAS. 3 plus 5 is 8, and you get the answer is 8x. And I'm hoping that this helps you realize this, because some people are like, oh, when you have squares there, so 3x squared plus 5x squared, sometimes students will say, oh, that's 8x to the fourth. Well, that's because you accidentally added the exponents. But if you think about it this way, that x squared is basically like a common factor, that using the distributive property, you could write it like this, then you see why the answer is 8x squared. And why it also helps is to see why you can't combine these terms, because you cannot factor, because one has x squared, you can't factor out a common term. So you cannot combine those terms. There's no way to simplify. I mean, you could factor out an x, right? All right, so if we did this, if you said, well, look, they both share an x, so I would be left with 3 plus 5x remaining. You cannot combine 3 and 5x. So that's not very useful, and you realize that this cannot be simplified, okay? So they cannot be combined. So understanding this will help you to avoid common mistakes when adding and subtracting polynomials. So let's just add and subtract polynomials by practicing with actual examples. So if you had to add these two binomials, you don't really need parentheses there, right? If you see parentheses, you can really just think that there's technically just a 1 out there, and you could apply the distributive property again, but it's more work than necessary. So you can rewrite that as 3x plus 6, and this is just 2x minus 4. And then you would be able to combine like terms. So as we did in the previous slide, so we could do 3x plus 2x, so that would give 5x. And then just for a different color, we could do 6 and minus 4, and that would give 5x plus 2. Now let's take those same binomials and subtract them this time. Now it kind of matters that you think about what's in front, especially of the second binomial, there's a minus 1 there, because that is going to be distributed in order to remove the parentheses. So 3x plus 6 minus 2x. Negative 1 times negative 4 is plus 4. And again, if we combine, let's see, like terms, 3x minus 2x, that would be just 1x. You don't have to write the 1, but you can. And then 6 and 4 would be plus 10. So let's now take an example of a binomial added to a trinomial. So 3 minus 5x squared, again, because it's plus, you can just combine it like this. Let's see, plus 1. And we can see that negative 5x squared plus 7x squared is 2x squared. Notice that there's only one term with the degree 1. That's called a linear term, minus 2x. So there's nothing to combine that with. But then we have the 3 and the 1, which makes plus 4. And for our last example, let's just subtract those. So distributing the negative 1 into the second parentheses, we get plus 2x minus 1. And negative 5x squared minus 7x squared is negative 12x squared. The plus 2x just stands alone. And then 3 minus 1 is plus 2. And we have the answer. So we'll end with this practice problem that kind of ties all the concepts we've been learning together. We have here a binomial. Let's see. So the first thing we're going to do is release everything from parentheses. So this binomial will just be 1 minus x squared. The trinomial that we're adding to that, again, because of the plus in front, we can just release it from parentheses as is. But here, with this trinomial, we have to distribute the negative. So we get minus x cubed plus x minus 1. And now we look at what they have, let's see, common terms. So we have a plus 1 here, a plus 1 there, and a minus 1. These cancel, leaving us with just 1. And let's have a look. We have a minus x squared plus x squared. How convenient. These cancel also. Let's get a different color. We have a minus x and a plus x. So they cancel, and we're left with only one term in degree 3. So we have 1 minus, oops, sorry, let me just erase that. Get the same color, 1 minus x cubed. So to answer the questions about leading term, etc., let's put this into standard form with the highest degree first. Don't forget to bring that negative that belongs with the x cubed. So the leading term is minus x cubed. The leading coefficient is minus 1, and the degree of the polynomial, of course, is the degree of the leading term, which is 3. Before you go, if you enjoyed this video, well, enjoy might be pushing it a bit. If you found this video helpful, please do check out other videos on my channel, Ready to Derive, and if you would be so kind and subscribe to my channel, I'd be eternally grateful.